Welcome to the deep dive. Today, we're going to be looking at numbers
Okay.
from 1 to 100.
Sounds pretty simple.
It does sound simple, and
Yeah.
and that's kind of what's so cool about this deep dive is that we've got this resource from Open Educational Resources and Open Source Physics at Singapore,
Mm-hmm.
and they're looking at it from the perspective of primary school math.
Right.
But even just in preparing for this episode, I found some really fascinating stuff about odd and even numbers and multiples and factors.
Oh, yeah.
So get ready to kind of have your mind blown a little bit about the building blocks of math.
It is amazing how some of these simple concepts that we learn in elementary school actually have a lot of profound implications for advanced math.
Yeah. Let's start with something we encounter every day, right? Odd versus even numbers.
Yeah.
We all know the basic definition: an even number can be divided by 2. An odd number can't.
Right.
But this resource actually takes it a step further.
Yeah.
And they have this clever visual, and they say, imagine lining up a group of kids in pairs.
Okay.
Everybody has a partner.
Yeah.
Even number 1 kid's left out.
Uh-huh.
Odd number.
I like that visual.
It's so simple.
Yeah, it's really effective, I think, for illustrating the core concept of parity.
Okay, parity.
Yeah.
So we're not just talking about, basic arithmetic here.
Right. And it goes way beyond that.
Okay.
For example, in computer science,
Yeah.
parity bits are used to detect errors in data transmission.
Parity bits. Okay, I'm intrigued. Now tell me more.
So imagine you're sending a stream of data,
Mhm.
and it's represented by zeros and ones.
Okay.
A parity bit is like an extra bit
Okay.
that's added to the stream,
All right.
and it makes the total number of ones either even or odd, depending on the system.
Okay.
So if the received data has an incorrect parity,
Uh-huh.
it signals that an error occurred, during the transmission.
Oh, that's incredibly clever. So we're
Yeah.
using the concept of even or odd to detect errors in computers.
Yeah, it's a really simple but effective way to do it.
That's amazing. I never would have thought of that.
Yeah, it's really a testament to the power of these fundamental mathematical concepts.
Yeah.
They pop up in unexpected places.
Yeah.
And speaking of unexpected, did you know that parity plays a role even in physics?
Okay, now you've really got my attention. Parity in physics. What do you mean?
Well, let's take the spin of a particle.
Okay.
So it's a property that can exhibit even or odd characteristics.
Mm-hmm.
And this parity helps physicists describe and predict how particles will behave.
So this is a fundamental concept that connects seemingly totally different areas of science.
Exactly. It's all connected.
That's mind-blowing. It really shows how something we learn, in elementary school can have implications for understanding the universe.
Absolutely. And that's just the tip of the iceberg.
Yeah.
Even concepts like multiples, which the resource defines as the results of multiplying a number by any whole number,
Okay.
have surprisingly broad applications.
Yeah, the resource talks a lot about skip counting as a way to grasp multiples.
Right.
So you skip count by 3, you get 3, 6, 9, 12, all the multiples of 3.
Exactly. Skip counting is such a fantastic tool
Yeah.
for visualizing that pattern
Yeah.
and making the concept more intuitive.
Yeah.
And multiples are everywhere in our daily lives too.
Oh, yeah.
From buying packs of items to understanding musical scales.
That's true. Music has a lot of patterns and multiples in it.
Absolutely. It's all based on that.
Okay, so let's move on to factors then.
Okay.
This resource defines factors as the numbers that divide evenly into another number.
Right.
And they suggest this neat trick.
Oh,
Pairing the first and last factors and then working inwards.
okay.
So for 12, you'd pair 1 and 12,
Mhm.
then 2 and 6, then 3 and 4.
I like that. That's a great way to visualize those relationships
Yeah.
between the factors.
Yeah, and understanding these relationships is really key for all sorts of things, from simplifying fractions to cryptography.
Cryptography. Hold on. Are you saying that factors play a role in codes and cybersecurity?
Absolutely. Prime factorization, which involves breaking down a number into its prime factors,
Mm-hmm.
is fundamental to a lot of encryption algorithms.
Wow.
It's how we secure our digital communications.
I'm starting to see now how all these really basic concepts from just the numbers 1 to 100
Yeah.
are woven into so many aspects of our lives.
It's incredible, isn't it?
It is. And we're just getting started.
Yeah, and we've only just begun to explore the depth and the richness hidden within these seemingly simple numbers.
This is already so much more than I expected.
I know, right? It's fascinating stuff.
It's funny, when you think about it, we kind of take for granted how we represent numbers.
Yeah.
We just see the symbols 1 through 100
Right.
and don't really think twice about
Yeah,
it.
we just use them every day. Yeah, but this resource actually goes into like the history of number
Oh,
systems.
cool.
And it's fascinating to think that our like familiar base 10 system
Yeah.
wasn't always the norm.
Right. Different cultures developed their own ways of counting
Yeah.
and representing numbers.
It mentions like the ancient Babylonians.
Oh, wow.
Like with their advanced astronomy, they used a base 60
The
system.
base 60?
60,
Wow.
which is why we still have 60 seconds in a minute and 60 minutes in an hour.
Oh, that's right.
It's
Yeah.
like remnants of their mathematical legacy.
It's amazing how these ancient systems still influence us today.
Yeah, exactly. And their system was like super sophisticated.
Yeah.
For its time allowed for precise astronomical calculations and even influenced like early timekeeping methods.
It makes you wonder, like, what if history had taken a different turn?
Totally.
Would we all be using base 60 now?
Yeah. What would that even look like?
I don't even know. It's hard to
It
imagine.
really shows how much our perception of numbers
Yeah.
is shaped by like cultural and historical context.
Exactly.
And speaking of different systems, the resource also mentions the Mayans
Okay.
and their base 20 system.
Base 20. Wow.
And it's really cool because their sophisticated understanding of astronomy and calendars
Right.
really shines through in their numerical system.
So they were really advanced for their time.
Oh yeah, they were incredible. Their system was based on the number of fingers and toes.
Oh, interesting.
So it was really connected to like their worldview,
Yeah.
and it allowed them to track like these intricate cycles of time
Wow.
and make remarkably accurate astronomical predictions.
So even without, like, modern tools,
Uh-huh.
ancient civilizations developed some pretty complex systems.
It's amazing what they were able to do. It's a real testament to human observation and ingenuity.
It is.
And you know what's interesting is these ancient systems are more than just like historical curiosities.
Right.
Think of like binary code that's used in computers today.
Oh, yeah.
It's essentially a base 2 system built entirely on zeros and ones.
So we're still using those ancient concepts in our technology today.
Yeah, it's crazy. We tend to think of technology as like cutting edge,
Yeah.
but it's really built upon like centuries of mathematical exploration and innovation.
It's all connected.
And this resource doesn't just explore like the historical context.
Okay.
It also brings these concepts back to like our everyday lives.
Right.
There's a section that explains how understanding multiples can help you like figure out quantities quickly.
Oh, that's useful.
Yeah, like if you're buying packs of something that come in groups of 6,
Yeah.
knowing your multiples of 6 makes it super easy to calculate how many you're getting.
Or it can save you time at the grocery store.
Totally. And they even connect it to music,
Oh, cool.
explaining how musical scales and rhythms
Uh-huh.
are often built around multiples and patterns.
So music and math are really intertwined.
Yeah, it's all about the patterns and the relationships between numbers.
Exactly.
It's mind-blowing to think that the same mathematical principles that govern like the harmony of music
Yeah.
are also at play in like the structure of the universe.
It's a pretty profound thought.
It is. But what I find particularly fascinating is how this resource emphasizes the importance of play and exploration in learning math.
Yeah. Learning should be fun.
Exactly. It shouldn't feel like a chore.
Right.
It should feel like an adventure.
Absolutely.
And they really go beyond just presenting like definitions and formulas.
All right.
They offer interactive games and activities
Oh, cool.
that make learning about numbers fun and engaging.
That's a great approach.
Yeah, I love the section where you can like create your own number pattern
Oh, wow.
and explore their properties.
That sounds like a lot of fun.
Yeah, it's all about fostering a sense of curiosity and wonder.
Right.
Like when you're allowed to play with numbers
Mm.
and experiment and make connections for yourself,
Right.
math becomes less about memorization
Yeah.
and more about discovery. And
Exactly.
I think that's like a key takeaway from this deep dive.
Okay.
Learning should be a joyful experience. It shouldn't feel like a chore. It should feel like an adventure.
Well said.
And that's what makes this resource so special. It
Yeah.
reignites that childlike wonder about the world of numbers.
I agree.
Wow, it's amazing how much we've learned just from these simple numbers 1 to 100.
It is.
From like basic concepts to like mind-blowing applications in technology.
Yeah. And physics,
In
dude.
physics, yeah, it's clear these numbers are way more than meets the eye.
They really are the foundation for so much.
And what I really appreciate about this resource is that they don't shy away from like exploring those deeper connections.
They really delve into it.
They've really managed to make math feel like accessible
Yeah.
and even exciting, which I think is like
Yeah, that's not easy.
not an easy feat.
No.
And I think that's a key takeaway here, you know?
Yeah.
Learning should be a joyful process,
Absolutely.
filled with curiosity
Yeah.
and a sense of wonder.
Mhm.
It's about, like, fostering that desire to explore and make connections. You know, to see the beauty and the elegance
Yeah.
in the patterns that are all around us.
Well said.
And speaking of patterns, I want to leave our listeners
Okay.
with a little challenge.
All right. I like a challenge.
Something to ponder as we wrap up our deep dive.
Okay. All righty.
So we've talked about how understanding numbers, like, helps us navigate the world.
Right.
But what about the numbers themselves as objects of fascination?
Oh, that's interesting. So you're saying we go beyond just like the functional aspects of numbers
Yeah,
and look at them as something interesting in themselves.
exactly. Like, think about prime numbers.
Okay.
They're only divisible by themselves and one.
Right.
And they seem to pop up in these, like, unexpected places,
Yeah.
like the arrangement of sunflower seeds
Oh.
or the life cycles of cicadas.
Yeah, there's a certain mystique to them.
Yeah.
Like they hold secrets we haven't figured out yet.
There are so many other examples, too, like Fibonacci numbers
Oh, yeah.
with their spiral patterns found throughout nature, or perfect numbers where the sum of their divisors equals the number itself.
Mm-hmm. It's amazing how much depth there is.
It's a whole world of numerical wonder out there.
It really is.
So to our listeners, I challenge you.
Okay.
Pick a number, any number,
Right.
and just delve into its history, its properties, its significance.
Yeah. You might be surprised at what you find.
You might be surprised at what you find. It's a reminder that even in something as simple as the numbers 1 to 100, there are layers of complexity and beauty just waiting to be discovered.
I completely agree.
And that is what the deep dive is all about.
Couldn't have said it better myself.
So until next time, keep exploring, keep questioning, and keep those brains buzzing.
See you next time.